Welcome everyone. I am Michelle Briggs, the Chief Park Ranger at the Soo Locks, and I can say that because I'm the only park ranger at the Soo Locks. My preferred job title is Lone Ranger, but so far I have not been able to get that put on my name tags. I have a master's degree in history and focused my studies on Great Lakes maritime history and museum studies. I've been with the Corps of Engineers at the Soo Locks since 2009. I work with the visitor center exhibits and displays. I do a lot of the photography that you see on social media and in the visitor center. And of course, in this program, I took most of the photos here, or there's just a handful that I have had to borrow from other people. My program's loosely arranged around a year of operations at the Soo Locks, but it includes a little bit of everything, including winter work, engineering, boats, and history. I'll also warn you in advance that I am a boat nerd, and there are some gratuitous boat images randomly inserted in the program. So, starting off in January, the shipping season at the Soo Locks officially ends at midnight, January 15th, and this has been the established date since 1991. So most boats have stopped running for the season by then. There aren't a crush of boats waiting to get through most years. Sometimes the last boat arrives during the day, which is my favorite because conveniently I am still at work to get the photos. But sometimes it comes later in the evening and I have to stay late or come back after my supper. But sometimes the last boat arrives just in the nick of time, like the Presque Isle in 2017, which arrived just about maybe 40 minutes before midnight to make its last lockage. And sometimes the last boat doesn't make it in time at all. Congress set the date, January 15th, as the closing date, but technically, boats leaving Lake Superior ports by midnight on the 14th can still transit the locks. This photo was taken in the early morning hours of January 17th in 2015, a particularly bad winter for navigation, you might remember. A quick sidebar, sometimes the last boats don't make it to the locks at all to get there through the lock in time. In 2014, the Arthur M. Anderson had to fight ice on its way up and did not make it to any of the check-in points in time to use the lock. The coal they were bringing for the Esser Algoma steel mill just above the locks had to be unloaded at the Carbide dock in downtown Sault Ste. Marie. This photo and the next one were shared with me by David Kay. If they had made it to the mill, they could have delivered the coal in about 8 hours. Instead, it took a fleet of trucks running all day and into every evening about 3 months to deliver this coal to the mill just across the river. And a sidebar, back to the lock operations. Once the locks close, crews begin the process of dewatering the lock. Here, they're lowering stop logs to form a temporary dam. We use a different setup now to lower logs, but this is one of my favorite photos, so I went ahead and left it in. This log weighs about 20 tons and is just over 80 feet long to span the width of the Macarthur lock. It's so well balanced that the two guys that you see pushing it over here are able to maneuver it into place just by slight movements. These logs slide into slots that are built right into the lock wall. The two men on either side of the log are helping maneuver it into position and watching to make sure the wheels don't get hung up. The third man, who you see signaling, is the signalman who's communicating with the crane operator. These steel logs rest one on top of the other to stop the water from entering the lock. This is a picture of the new process we use, setting the logs from a modular barge with our newest crane. If you notice that there seem to be a lot of extra people around, you're right. But this is all new equipment, a new procedure, and we want to make sure to get as many people as possible trained on this. And as you can imagine, this isn't the sort of thing we can do when the locks are in operation. At the lower end of the locks, we use a tugboat to push a set of guard gates together to form a temporary dam. These gates do not have operating machinery like the lock chamber gates, so crews use capstans on the lock wall as well as a tug to push the gates into position and hold them closed. The force of water pressure on the gates will hold them closed once the water level in the upper level is dropped about 2 feet. Speaking of dropping the water level, it starts with the opening of some valves, allowing water to flow into what is essentially a supersized sump pump. From there, we have 5 pumps that pump out the water. This is the only reason we ever use pumps, when the water level in the chamber has to be brought below the level of the lower river. You might have wondered about that strange word dewatering, and why don't we just say that we have to drain the locks? Well, to drain, you require moving water through gravity. And of course, unless you're at the mystery spot, water won't flow uphill, so we have to use pumps when we have to change the water level below the Lake Huron level. This photo shows 2 of the 350 horsepower pumps. From there, we have 5 pumps that pump out the water. This is the only reason we ever use the pumps. This is 2 of the 350 horsepower pumps. And the other 3 pumps are 300 horsepower each and are original to the Davis building. As a matter of fact, the Davis building was built around these pumps, as you can see from this 1914 photograph. These pumps still use the original 5-foot discharge pipe that you see in this photo from 1913. In the background, you can see an on-site concrete plant right over here that was used during the construction of the Davis Lock. But I'll talk about Soo Locks history in a July program. Oh, here's one of those gratuitous boat shots that I warned you about. I think it's a particularly pretty shot of the Ryerson, although of course it would be much better looking if there weren't all the fences, or if it was going through the locks, of course. Back to business. Once the stop logs are all set and the guard gates are closed, divers go into the water to chink up any leaks in the stop logs. During most winters, we also place one of our crane barges in the lock chamber. This photo shows the Harvey as it's being lowered to the lock floor as the water is pumped out. This allows us to not only use the crane to move materials and equipment in and out of the lock floor, but it also lets us use the chamber as a dry dock to complete hull inspections and repairs during the off-season. Here's a view of the dewatered Macarthur lock. And just to be fair, a view of the pole lock taken from the lock floor. This is one of my favorite pictures I've ever taken, not of a boat. By removing the water, crews and engineers are able to work on and inspect parts of a lock that are otherwise inaccessible. We'll do a sort of walkthrough through the interior of the lock monolith starting at the upper end. So we'll start out going into the lock way up here at the far end. This is just inside the filling ports at the upper end of the locks. This photo shows the openings in the Macarthur lock where the water flows into the culverts to raise the water level in the lock chamber. This photo was taken pretty soon after dewatering because the floor is water covered, not ice covered. To get your bearings, hopefully this construction photo helps. At the upper end, way up here, are the filling ports, which are the openings that let water flow into the culverts. The culverts are right here in the base of the lock monolith, and they're angled downhill to allow water to flow in and fill the chamber, which would be this portion of the lock, and then flow out through the outlet ports at the other end.
I want them to see us. That's what that is.
Within the culvert, there are reverse Tainer valves at each end of the Macarthur and Poe locks. This is one of the valves at the lower end of the Poe locks chamber. This is a huge mechanism, and it's almost impossible for me to photograph it and really show how big it is. This drawing shows more of the mechanism. This part right here is what is featured in this photo. So the rest of the mechanism is up above it, and if you can imagine the size of this valve, this goes all the way up to the surface, the sidewalk level. And there are 4 of these valves, 2 at the upper end and 2 at the lower end. They're the filling and emptying valves. Sorry, I'm being attacked by a cat. Working our way down the culvert to the lower end are the outlet ports, also huge and hard to illustrate just how big they are. I'm not sure if this helps, but I particularly like this photo I took this winter of one of the crews heading out for their lunch break. When the lock is empty, you can also see just how large the lower gates are, almost 60 feet tall and weighing 225 tons each. Oh, another gratuitous boat photo. This time we've got the Edmund Fitzgerald going through the Macarthur lock. I'll talk more extensively about winter work during a July program, but for now, just a glimpse of the kinds of work our guys do during the 10 weeks the locks are off service. This photo shows one of the upper gates resting on cribbing. That's these wooden beam cells stacked up here to support the gate. And they've raised the gate so that the crews can get underneath it to repair and replace a pintle and pintle base. This is the pintle. It's installed directly to the lock. It's a semi-spherical orb, basically, made of stainless steel, and it's the pivot point for the lock gate. Right now, this one's all greased up and waiting to have the base set on it. The pintle base attaches to the gate and rests on top of the pintle. In this photo, two of our machinists are making some final adjustments to the new base in the machine shop. The base right here is being lowered by a crane to the lock floor. Anything too big to be carried has to be moved in and out of the lock using cranes. And here, I think this is 2015, a crew is replacing one of the lower sills in the Macarthur lock. The gates, when they're closed, rest against these concrete sills, kind of like the thresholds in a door in your house. This may or may not be the park ranger's handprints in the Mac sill. In 2017, crews replaced valve cylinders at the upper end. It's hard to see, but the guy in the fall protection gear here is working about 40 feet above the bottom of the culvert. His fall protection gear keeps him safe, but the dropping of tools from time to time adds a special layer of annoyance to his task. At the right, you can see the cylinder being moved into position. I mentioned that divers chink up the leaks in the stop logs, but they're still not 100% watertight. We can end up with some pretty cool ice formations. This ice also more or less locks the stop logs together. What you cannot see on the other side of the logs, on the upstream side, is what we call face ice. I mentioned that the logs are steel. Well, as you know, steel is an excellent conductor of cold. So when the temperatures drop below freezing for any extended times, as they do in the Soo, that cold is transmitted to the water against the dam, and it causes it to freeze. Lockmasters have told me that this ice is as clear as glass and can be as much as 4 feet thick on the upstream side of the logs. About 3 weeks before we re-water or refill the lock, crews start thawing the gates with steam lines. This photo shows this process underway on the Macarthur lock, which opens after the Po, which is why you can see a freighter way back there approaching the Po lock. I have a short video of getting the lock being re-watered, and I will warn you in advance the volume might be a little loud, so just be prepared in case you need to make an adjustment. You may notice that there seem to be a lot of people watching this process, and you are right. Seeing this in person is really impressive, and a lot of people will come out to see this each year. The video does not completely capture the noise or the vibrations in the gates as the water hits them. As the video pans, watch for the intake ports, which allow the water to start filling the chamber. Oops, sorry. And there it goes.
It's so annoying.
The next challenge for opening the lock is clearing the ice away from the walls so that the guard gates can be secured into place. Sometimes this goes pretty smoothly. Here you can see the guys using boat hooks to maneuver large pieces of ice out of the wall recess. Sometimes they have to bring out the big guns, in this case a huge airline with compressed air to get the ice moving. The tug is holding the gate in position to keep it from drifting back into the canal and allowing more ice to drift in. People pay a lot of attention to the first freighter of the season, but the very first boats are icebreakers upbound to start opening shipping lanes in Whitefish Bay. The first ship of the season sometimes arrives the day before the lock opens. The official lock opening date, by the way, is March 25th, and that also is congressionally set. In 2013, the boat arrived a day early, and a delegation of dignitaries from Sault Ste. Marie was able to greet it in the afternoon. and sometimes they have time to be invited on board to meet the captain in the pilot house and present plaques and gifts for the crew, like in 2017 when the Stuart J. Court was the first boat. The Soo Locks Visitor Center Association presents special hats to the entire crew of the first freighter of the year, and apparently they're quite the collector's item for some of the sailors. And just as an FYI, the first boat of the season is always the featured vessel on the association's annual Engineers Day t-shirt. In normal years, we also have special park hours for the first lockage of the season, and people brave the cold to watch and have bragging rights. Other years, the boat arrives later, like in 2015 when the Gott arrived mid-morning on March 25th. You may recall that this was a particularly bad winter, and the Gott had to fight ice the whole way up the river. It ended up fighting it some more trying to get out of the lock. It took several attempts and just over 6 hours for the Gott to get out of the Po lock that afternoon due to ice flowing in. And some years, the first boat does not arrive until April 4th. The first freighter of the 2014 season was the Cason J. Callaway, which had spent about 9 days in a convoy led by icebreakers to make its way across Lake Superior. This is a trip that normally takes 28 hours, so it took them 9 days. That year, they were not stopping for anything. The captain came down to the lock wall to meet the local dignitaries, have a quick television interview, and got right back on board and started fighting his way downriver. Icebreakers don't operate at night, so that they did not want to waste any daylight to make more progress to get to their destination. I mentioned that 2014 was one of the worst winters we had for ice on the Great Lakes, and I mentioned that the Callaway had been part of a convoy that had been crossing Lake Superior. That season, while the ice was at its worst, all upbound traffic had to travel in convoys of 5 vessels escorted by icebreakers. This aerial photo from the U.S. Coast Guard taken April 19th shows boats waiting for their turn to join a convoy and get underway. They're a little hard to see, so these arrows point to the 16 boats that are all waiting in Whitefish Bay to start heading across Lake Superior. A little sidebar here. The U.S. Coast Guard are important partners for the U.S. Army Corps of Engineers in our navigation mission, and the 104-foot-long Bay-class cutters are some of the most reliable workhorses year-round. They break ice in the winter and tend buoys in the summer. These cutters have a unique air bubbler system that helps lubricate the hull and prevent it from sticking to the ice. What you see right here along the bow of the boat here are the bubblers that are helping it move through the ice. To break ice, it pushes itself onto the ice, and the weight of the hull breaks it apart. This can involve a fair bit of backing and ramming, but eventually the track is established, and the wake from the boat helps create a track wider than the cutter. And it turns out they'll let just about anybody drive one of these boats. Of course, I was pretty closely supervised. On the Great Lakes, the U.S. Coast Guard works cooperatively with the Canadian Coast Guard, and the Samuel Risley is frequently seen here in the winter. In 2014 and 15, conditions were so bad on the Great Lakes that the Canadian Coast Guard shifted icebreakers that would normally work on the ocean to the Great Lakes, like the Martha L. Black. So, back to the locks. The beginning of the season is the most challenging for our lock and dam operators because the locks end up clogged with ice, and it can take hours for boats to get through. Imagine a snowplow with the blade down driving into your garage and then trying to pull open a door. That's basically what happens in the lock for a downbound vessel. With 1,000-foot-long boats like the Mesabi Minor, they're so wide that there's not enough clearance for the ice to work its way out around the hull. Sometimes the operators can use compressed air and carefully timed fanning of the gates. So basically, they operate the gates at different intervals to try to work the ice out of the chamber. Other times, the freighter has to back out of the lock, and we have to use one of our tugs to go in and act like a plow and clear the ice from the chamber. Another challenge for the 1,000-foot-long boats is ice building up on the guard gates, those gates that form the temporary dam at the lower end. The ice builds up on these gates, and if even a few feet of ice build up on either side, the footer will become stuck. The 1,000-footers, I'll remind you, are 105 feet wide, and the lock chamber is 110 feet wide. So it's a pretty slim gap that they have. Luckily, we have a system for that too. I have another video, and again, I will warn you that the volume might be a little tricky, so if you be prepared to make an adjustment. So, moving right along, I'll take a moment here to explain the process of how boats lock through and what's happening within the lock at each stage. When boats reach particular points within the river, they call the lockmaster on the radio to be dispatched. He monitors the traffic in the river and determines which lock and in what order boats will go through. Generally, it's first come, first served, but occasionally the lockmaster will change this in heavy traffic situations to move the most boats through the lock most efficiently. In the tower, he also monitors water levels throughout the river and provides up-to-the-minute information to the captains. Water levels in the river fluctuate, and it's not uncommon for boats to load to depths only a few inches shy of the project depths. So having this information is critical for them to know if they can proceed or need to wait for the water level to come back. This diagram shows a boat approaching at the upper end, and notice the two valves that I talked about, the filling valve and the emptying valve. Because water seeks its own level, gravity is what is causing the water to fill the chamber. By leaving the filling valve open, closing the emptying valve, the water will level itself here and reach what we call high pool as the boat is entering at the upper end. Out on the pier wall on the approach canal, in normal times, two deckhands are lowered to the pier wall on a bosun's chair to carry the lines as the boat approaches the chamber. If you'll note, that's quite a long drop. If you were with us last week, you got to see a video of this process from the deck of a boat. Meanwhile, a U.S. Army Corps of Engineers lock and dam operator waits at the lock chamber and takes over the lines when the boats get to the lock chamber. The lock and dam operators call out the position of the ship in the lock as it nears its mooring point and also use hand signals to communicate with crew members on deck. The core lock and dam operator, assisted by the deckhand, then drops the cables on the buttons, the yellow bollards that you see here all along the pier wall. These cables weigh about 175 pounds. In the operating shelter, the lock and dam operator leader operates the lock, lowering the boom and controlling the gates and valves. The panel you see here is the original 1943 operating panel for the Macarthur lock. This was recently upgraded, and I'm pleased to say that the original panels were used for exhibits in our visitor centers in Duluth and Sault Ste. Marie. The Soo version is coming this summer. So once the operator has closed the upper gates and lowered the safety boom, they close the filling valve and they open the emptying valve. Once again, relying on gravity, the water flows out of the lock chamber, through the culverts, and into the lower river. With each lockage of the lock, we move about 22 million gallons of water. Using gravity and the huge culverts you saw earlier, this takes about 20 minutes, roughly 1 million gallons a minute. By comparison, when we move almost the same amount of water from the lock using the 5 pumps you saw, it takes about 16 hours. While the boat's in the lock, someone from the crew goes to drop off their outgoing mail and pick up any mail that's waiting for them. The crew also drops off dirty laundry and picks up their clean laundry. This is not personal laundry, but generally kitchen linens, floor mats, and similar items. They have their own washing and drying machines on board for their personal clothes. Once their tasks on the pier are complete and the boat is low enough, the deckhands reboard. Within the lock, with the lock lowered to low pool, the operator in the shelter opens the lower gates and raises the safety boom. And the boat is on its way. Below the locks, many of the boats are met by a supply boat, the Ojibwe, which uses a crane on its deck to deliver fresh groceries and any equipment the vessel may have ordered. Operating the Soo Locks is probably the most visible thing we do in the Soo, but if you bear with me, I want to highlight some of the other critical things that go on to keep everything operating. The Soo Area Office has several tugs, barges, and small craft manned by captains, derrick barge masters, and deck equipment operators. These vessels work at the locks throughout the river, doing surveys and removing debris from the channels to ensure a safe passage for loaded freighters. We have mechanics that work on everything from small boat motors to stiff leg cranes. You can see that's not exactly a workstation I would be in favor of. We have a whole team of electricians that keep the lights on, maintain the cameras on the control tower, and design and build custom electronics for operating equipment. We generate 150 million kilowatt hours of electricity each year in 2 on-site power plants. Here's a view inside the new power plant with its 4 turbines. We have machinists that work both in the shop and out on 60 feet above the lock floor. We have carpenters that do everything from minor repairs to technical projects like maintaining our historic landmark buildings and handling everything from replicating original moldings and trim to repairing plasterwork. As I mentioned, we're a National Historic Landmark, one of fewer than 3,000 in the country, and we take great care to preserve the historic fabric of the site. I'll do a full history program of the Soo Locks in July, but meanwhile I want to share some then and now pictures. This photo was taken in July 1946, and despite some changes in the fencing, probably still looks familiar to any of you who have been to the Soo Locks. The building we now call the Administration Building was originally built in 1896 and had a turbine power plant in its basement. Notice the workers on top of the tower. Safety standards were a little different back then. I don't think it'll show on your monitors, but when I zoom into this photo, there's also a little girl right here. And if you look, this is clearly a construction area. There's not even a roof on this building yet, but somehow there is a little girl standing there by herself. The control tower at the top of the Administration Building has changed from the original design, but otherwise very little has changed in the past 124 years. Here's a photo of the lobby of the Administration Building while work was underway, and a photo of what it looks like now. Again, very little has changed. I'd like to note that in a normal year, during Engineers Day, on the last Friday in June, the first floor of this building is open for the public to visit. Originally called the Pump House, and you saw the pumps being built in its basements, this is the Davis Building from 1914. It was named for the lock next to it, which is named for Detroit District Commander Colonel Charles E.L.B. Davis, who held that position from 1904 to 1908. And who knows, maybe someday this will be famous as being the office of the Chief Park Ranger for the Soo Locks. The very first power plant in the Rapids was built in 1887. It's not this plant. This plant here replaced that original plant in the early 20th century. And then this addition you see over here was added in 1932. And that 1932 addition is still there and generating electricity with a single turbine. Oh, there we go again. Edmund Fitzgerald, this time downbound in the Poe Lock in April 1971. Of course, the whole purpose of the Soo Locks is to keep ship traffic moving efficiently, and this photo is a great illustration of why we once had thousands of freighters on the Great Lakes and now have less than 100 permanently operating here. The boat on the left is a 1,000-foot-long Burns Harbor, and its fleet mate next to it is a 680-foot-long John J. Boland. The Indiana Harbor, or Burns Harbor, sorry, the Burns Harbor there has a cargo capacity of 80,900 tons. That is basically 700 rail cars, or about 2,300 semi-trucks. The Boland has a carrying capacity of 34,000 tons. Older Lakers, like the Arthur M. Anderson, have a carrying capacity that tops out around 25,000 tons, roughly the same as the Edmund Fitzgerald. So a footer can carry the equivalent of roughly 3 1950s era Lakers. The scale drawing shows the growth of vessels over time and really demonstrates the efficiency of today's cargo vessels. At the bottom, you see the footer with its 80,900 ton capacity. Above that, a mid-century freighter carrying about 20,000 tons, an early 20th century freighter, which carries about 8,000 tons. At the lower right, a late 19th century schooner carrying approximately 2,500 tons, and an early 19th century schooner with a capacity of about 300 tons. And finally, Way up in the top, oops, sorry, going the wrong way. Way up in the top, a Montreal trade canoe, about 35 feet long and with a capacity of 4,000 tons. Part of the efficiency of these vessels depends on the ability to bypass the rapids in the St. Mary's River. At this 3/4 mile stretch, the river drops 21 feet over boulders. Before there were locks, every vessel had to be unloaded above the rapids, and the cargo and canoe carried about a mile around the rapids and reloaded below. The first lock at the Soo was built in the 1790s when trade canoes were the workhorses of shipping on the Great Lakes. The Northwest Fur Company built this one on the north shore of the river and operated it until a party of American soldiers destroyed it in 1814. For the next 40 years, all cargoes had to be carried around the rapids, and in Sault Ste. Marie, warehouses and a strap railway were installed to store and transport cargoes around the rapids. Even boats. This was the first steamboat on Lake Superior. It was built in Chicago. It came up Lake Michigan, through the Straits of Mackinac, up the St. Mary's River, and in Sault Ste. Marie was hauled out of the water and pulled up Portage Avenue and relaunched above the rapids. This process took 7 weeks. One thing I like to point out too, if you'll notice these kind of strange propellers, if you come to the park at the Soo Locks, we have one of those original propellers in the park. This boat blew up about 3/4 of a mile above the locks in 1854, and somebody salvaged the propeller. Believe it or not, talk of building a canal around the rapids was not universally popular. The locals in particular were opposed to it, as it would end the thriving business they had warehousing and transporting goods. Senator Henry Clay of Kentucky in Congress argued against the project, claiming that there was no point spending money on a place as remote as the moon. That is a direct quote, remote as the moon. Luckily for Great Lakes shipping and industrial development in the Midwest, President Millard Fillmore saw it differently and claimed a ship canal around the falls of St. Mary's of less than a mile in length, though local in its construction, would be national in its importance and benefits. So in 1852, the state of Michigan received a federal land grant to finance the construction of a set of tandem locks at the Soo. Construction began in 1853, and the locks opened for business in 1855. There have been locks in operation here ever since, and we typically pass 70 to 80 million tons of raw materials through the locks each year, primarily iron ore, coal, stone, and grain. The value attributed to this, according to a 2014 study, was $500.4 billion to the U.S. economy each year. As winter sets in, the crews of the Great Lakes freighters and our lock and dam operators definitely earn their wages. Winds were clocking in around 20 miles an hour with driving snow on this day, and everyone outdoors was in penguin mode. Back to the wind, arms and legs tucked in tight, including yours truly out taking the picture. The winch operators on deck would turn, make adjustments to the lines, and turn back during the entire lockage. You'll see them standing there, just like penguins. Out in the lakes, they encounter some heavy weather, which they sometimes are still wearing when they reach the locks. This photo of the Presque Isle is absolutely beautiful, as is this shot of the Edwin H. Gott. And check out the close-up of the ice on the Gott. I cannot imagine what kind of weather you go through to get curly-Q icicles like that. But for the crews, this just means a lot of back-breaking work and slippery working conditions. These guys on the Algoma conveyor had been using ice spuds to chip ice from the deck for almost 4 hours when they passed my office. A first mate I met a few years ago told me one of the hardest things about working on deck in winter was no matter what you wore or how much you ate, you were never warm and never full. And frankly, looking at the work ahead of these guys, and it was just these 2 guys out there, I can definitely sympathize. It's only slightly better for our lock and dam operators who log hours in bobcats blowing snow, walk miles behind snowblowers, and break out the shovels for the places too steep or too slippery for anything more than a shovel. And eventually, January 15th rolls around again, and it all starts over. One thing I'd like to point out with this photo, This is the Philip R. Clark, and it is tied up at the lower end facing downbound, which anyone familiar with the Soo Locks will know that you pretty much never see a boat stopped downbound on the lower piers. If you also notice, all around this boat, that is not water, that is ice. So that boat is basically frozen into position. They had stopped there for the night, waiting for the Coast Guard to break them out and to escort them downriver. And with that, I will open up for questions.
Michelle, we had a couple questions so far. One is it possible for a ship to be so heavy that it touches the bottom of the lock?
Nope, because they float. They all float.
Okay.
If they loaded their draft too deep, then that could be a factor, but they do not load their draft deeper than the project depths. The project depths in the river at the upper end are 28.5 feet. And so they base all their loading on that. And we're slightly deeper at the locks.
Okay. Another question, is it allowed to swim through the lock? I read somewhere that someone had swam through the Panama Canal.
It is not allowed to swim through the lock. As a matter of fact, we require all vessels to be under their own power. And so you can't go through in your kayak, your pedal boat, or your rowboat either.
Okay. What about the number of people that work at the Soo? Did you address that already?
I did not. There are about 130 full-time employees, and there are a crew of maybe about 30 or so people who are the lock and dam operators, who are the ones you see out on the lock. But we have other people that work in the offices. We have engineers. We have our hydropower plant operators, and we have a huge maintenance staff.
Okay.
And of course, one park ranger. I see someone is asking, has any presidents visited the Soo Locks? Yep. President Taft visited the Soo Locks. I actually, in the, I think it was the Clements Library, saw a picture of President Taft in his open car in front of the Soo Locks Park.
Hmm. There's another question about can you talk about the rock cut project? What year was it established?
Sure. The rock cut was begun in 1902 and it was finished in 1908. It actually is channeled out of solid rock. And it was, I don't remember what the project depth was when it was built, but in 1908 it was opened, and that allowed for two-way traffic around Neebish Island. Before that, all traffic had to go on one, and basically had two-way traffic on one lane around Neebish Island, and it was a site of a lot of collisions and a lot of close calls. And by setting up two-way traffic, it smoothed out the whole operation there and made it much safer. It had to be deepened in the 1930s and again in the 1960s. Hope that answered your question.
Another question, how are fish and other wildlife affected by the lock?
The occasional fish does come through, and occasionally it ends badly for that fish, but it may go bad for the fish, but it's a benefit to the seagulls. But for the most part, most of the fish are more attracted to the natural habitat outside of the lock. The lock floor, as you saw from the photo of the dewatered structure there, is concrete, and most of the fish will kind of stick to the more natural terrain around that.
Okay, someone else asked, how many boats go through the locks in a given year?
We have about 7,000 passages. We have two ways we count them. We count them as lockages and passages. And passages is trips by a boat. So if we have a lockage with two boats in it, that's two passages. Of course, that is going to be double counting boats that make more than one trip through the locks, of course, and some of the boats, like especially some of the 1,000-footers, might make up to 80 trips a year through the locks.
Okay. Another question. Hi, Michelle. Seeing lots of salties going through the St. Mary's with so many boats in layup. Is shipping up or down so far this year?
You know, I am not sure. I think it is probably a little down because there are so many in layup, but I have not been in my office. As you can see, I'm in my telework dining room. And so I haven't had quite as much contact with our recording clerk as I usually do to keep track of these things.
Okay. Another question. At one time, hundreds of Soo Locks historic glass plate negatives were going to be digitized. Did that happen, and how are they accessible?
That did happen, and they are accessible if you go to the Clark Historical Library. They have an online database of all of these photos, and it's a wonderful resource because you can do keyword searches, you can just browse, and you can find all of those photos there.
Great. Another question. Do passengers ride these vessels also?
Well, there are not passengers on the freighters per se. Of course, there are Soo Lock tours. So we have passengers on Soo Lock boat tours, and we do lock through personal watercraft, which of course are going to have passengers. But freighters are not licensed as passenger vessels, and they do not carry like passengers like on a cruise line. Sometimes shipping companies will have special guests on board or company VIPs, but they do not like offer passage fares for the public.
Okay. How much does a ship pay to go through the locks?
That is a great question, and they do not pay a toll per se. What they do, and then their cargo taxes go into a harbor maintenance trust fund, and then we get operating funds out of that harbor maintenance trust fund. So if you go through in your speedboat, you're not going to pay anything directly. It's kind of like you don't pay anything to drive on I-75 directly. You're not paying a toll, but you do pay in other ways.
Great. Well, there's a bit of a lull in the questions. I just wanted to let everyone know about our facility status, both at the Soo Locks and at the Duluth Visitor Center. The St. Mary's Falls Canal Parks in the Soo Locks opened last Friday, so they are open now. But the Visitor Center at Duluth and the Soo Locks are both closed, and that's including the viewing platform at the Soo Locks. We're planning a phased reopening, starting with staff returning to work and increased outdoor interpretation. And of course, we're going to keep doing these virtual visitor center programs. But right now, we don't have dates, and we'll just keep you updated with this every week. And also, our social media will have updates on our opening as well. And finally, we've got our contact information on this slide here. Our next program coming next week is educational programming at the Lakes Pier Maritime Visitor Center. And if anyone on the chat today knows any educators or group leaders, this is a really good presentation for them to attend because it goes through what we do at the Visitor Center and all the educational programming that we offer and we'll be offering in the future. So that's good information. And then just a couple of links to our Facebook pages, our web pages, and we've got a survey as well that there's a link in the chat for that directly that you can go to and take a survey just to help us improve our programs and give us some feedback on what we've been working on. I'm going to keep that up, and we've got a couple more minutes, so if anyone thinks of any other questions, you can feel free to put them in the chat. Someone asked if they can replay this program. Yes, on our Facebook links and on the USACE Detroit YouTube channel, we're going to put the recordings of these programs on there. They'll probably be on by tomorrow or the next day. So yes, you'll be able to watch these programs after our live session today.
Hello?
Hello?
Yes. This is Craig Serpent. I'm calling from down near Lake St. Clair. And I have to say this is the first one of these programs I've seen, and I very much enjoyed it. So congratulations to you folks. You did a very, very nice job.
Thank you.
Yes, down here, of course, a lot of people are worried about the levels of water in the Great Lakes Basin, specifically around the shoreline and, Lake St. Clair and that sort of thing. And I was curious how, what could you share about the effect of the lakes, or the locks, I should say, on the levels of the lakes, both upper and lower?
Well, I'll jump in, I guess. We unfortunately are not water levels experts. We are park rangers and often jacks of all trades. But I will let you know that we are going to have a program next month that is going to be entirely focused on water levels with one of the physical scientists that we have in the district. And I have no doubt that she could answer all of your questions and more. Otherwise, I would recommend visit our webpage, the LRE U.S. Army Corps of Engineers webpage, and there are resources there about Great Lakes water levels.
So may I ask, do you think that I might be able to, I don't know if my local Clay Township or St. Clair County people know about this website and all the information you offer. I wonder if they wouldn't benefit by listening to such a program.
They probably would, and if you're able to give them a heads up, that'd be great.
Yes, I'll try and do just that. Thank you.
Okay, I don't see any more questions. So I'd just like to thank you all again thank you, Michelle, for the program today. It was very educational and interesting. And what else? Just another reminder, next week at 11:30 Central or 12:30 Eastern, another virtual program. And just like to thank you all again for participating today. And again, if you have a few minutes to do the survey, that would greatly help us improve our future programming and think of other ideas. So thank you very much again, and we'll be ending the program now.